Alright, hello. I'm Robert Salerno. I'm presenting my final project. So, we start off here by just an overview. So me and my partner, we did the air quality data. So, most of our cases, for our switch case, we use a menu, and then most of our cases are just plots of our data. And then you scroll down, we have our nested loop here. And you scroll down, we have a few of our visuals. We have all of our graphs are either plots. We have a bar graph here. Here is my partner's function, and then here's my function. We scroll back up to the top. Here's our histogram. Scroll back up to the top. We can start running a few of these cases. So if we go, we hit CO, carbon monoxide. So it plots our concentration, CO concentration versus the date. So it has right here on our Y label, we have CO concentration in mg over m cubed. So that's just what it reads in. And then on our X label, we have our date, our month, date, year. We have all that right there. And then see we have a plot 1 to 9,357. That is how many points we have. And then this is Y, which is what our XLS read is in. And that is all of the rows, second column. So if we go down the next one, with CO max concentration, prints it down here. Max concentration is this value. Next one, we go to tin oxide. So we see here, these are the values of tin oxide. And if you look, these values down here are values that did not record for the day, so those were set to 0. So there's a few of these stray bars throughout some of our graphs. Going on the next one is our hydrocarbons, non-metallic hydrocarbons. So then same thing, we have our date, and then our hydrocarbon concentrations, and then the title. And then down here you see once again we have some zeros here, and then here and here. I go to the next one, we got benzene. Very similar to the rest of them. And the next one, titania. You see here we have some zeros once again, just a few stray ones, not too many chunks. We go on to the next, NOx, similar. We have a lot of points here, not too many zeros, just a few right there. Next one, we have tungsten oxide, NOx, same graphs. We have NO2, very similar, not as many zeros here again. And then here we have NO2 max concentration, so down here prints out the value again. Go down to the next, we have high or low NO2 concentration. So let's just scroll down. This is our nested loop. So for our nested loop, you see here we have Z XLS read, so that just reads our data. And we have C is Z to all of our rows in our 10th column, so that's what we are doing the loop on. Then D is our dates, so that's all of the rows in our first column. So we have a row column equals size C, so that just tells you how big this is. And then we have our nested loop right here, A1 to row, B1 to column. And then if C, A, B, so that will tell you, 1, 1, 1, 2, 1, 3 is greater than 110. We have it make a date, have it F assign D, A, B, and then we go down here, and then it makes a date, and then prints out that date, and it says high concentration on the date you format here. If it is less than 110, we have right here, same thing, makes a date, everything, but F prints F, low concentration on that date. So we go down here, low concentration. So all these dates, it'll say high, low, high, low, high, low. and then it'll tell you high concentration on a day or low concentration. So we got on the next of our cases. We have tungsten oxide NO2, and this is our histogram. So we see here it's pretty decent bell curve, and then we have some of those zero outliers here, and so we see here have some of these zeros again, kind of just an outlier. So we don't really look at those, but we just look at these main curve. It's pretty good. Go down. We see here our histogram, case 12. Same, Y equals XLS read, and then we just do histogram, Y, all of the rows in the 10th column, because that is tungsten oxide, NO2. For our next case, we have indium oxide, same as a lot of the others, out of up and down, some zeros, not too much on this one. You know, we have the dates, the Y label, title. For the next one, we have temperature. So this is our curve fit. So we have for temperature curve fit, we have right here. Let's pull this up. So as we see here, this is our curve fit that we put in. So if we go through our code, we have first off our XLS read, reads our data, and then we assign B to read all of the rows in column 13, and then we find the length of that into a vector, and then for A we have linspace 0 to the length of the vector all the way to all of our values, so that's 93, 57 values. So we have P polyfit to AB, third degree. On the third degree gave us this good blue line right here. So we go on to the next, polyval. So polyval uses polyfit, and then A, which are those values. And then we plotted A, B with these red circles, which are all, this is all of our data. And then we go, hold on, plot A, X, so that is what plots this line. And it fits our data pretty well. Third degrees seem to work out pretty well. And then we have temperature curve fit up here, and then we have Y label, which are all the temperatures, and these are all of our values. So it goes from 1 to 9357. If we go down, we have our humidity. Humidity, we're going back to our normal plots we have. So this is a pretty good curve too. There are some zero values, not a ton. We go down the next, we have our bar graph. So if we look at what we got here, we've got tin oxide, titania, tungsten oxide, NOx, and indium oxide. So these are just they were some columns with comparable values. So we started off by XLS read, and then we made this vector 3, 6, 8, and 11. So that are these values 3, 6, 8, and 11. Those are just the columns I were in. So we did A equals the average of the third column. So that'd be this. And then B is the average of the sixth column, and then C is average of the eighth, D is average of the 11th. So we made all of those into a vector, so that would be these values, all of these values. And then we did a bar and an R, which is those, and then L, which are all those values, and then a magenta color. So we have the X label down here, tin oxide, titania, tungsten oxide, indium oxide. So that gives us this graph. If we go down, we are now going to our first function, Parner's function. So if we take a look at this, we have, once you hit her function, you see it pulls up another menu. So this is another switch case inside of the other switch case. This pulls up all of these cases. And if you choose a case, you'll see you'll see you'll get 3, 4, 5, all the way to 12. So if you choose one of those, say we choose 6, it'll add all the values in that column and then give you this number. So if we check out the function, you'll see it starts off with the function handle, her name, some concentrations. That's what it does. And then XLS read our data creates a vector from whatever you put. So this D would be either 3 all the way to 12, one of those values. So it'll give you a vector from all of the rows and that column, and then it'll find the length of that. Set an initial condition of S to 0. So then for 1 to L, the length, it'll be S equals S plus V of Y, and then increase Y plus 1, and then just keep going and looping until it's completely done with the data. So S will be 0, V of Y will be the first point, so it'll be 1, 3 if that's what you choose first. And it'll increase it by 1, the 2, 3, and then add that to the last value, and then add that value to 3, 3, and then 3, 4, or then 4, 3, and 5, 3, and just keep going until it does all of the addition. So then we get this right here. So if you choose 10, gives you a sum. So we go on the next function, we have my function, pull it up, we have, it'll find values, we have another case, so it'll say which column you want to find the value between 1000 and 1100, so say you want to choose column 8. Column 8, there's 739 values between that. So let's look at the function, XLS read, initial conditions of this, and then this will do it until R is less than all of our points. So if R equals all those points, it just breaks. And then it'll go right here, N and W. So N is whatever you choose, so that can be 3, 6, 8, or 11. And then W will initially be 1, or W will initially be 3, 6, 8, or 11. N will initially be 1. And then it'll increase by 1, make it 2, keep going and going and going. If that value is between 1000 and 1100, it will add 1 to A, and then keep going, and then if it doesn't, it'll just add 1 to N and see if the next value is that. So it's going to keep going until R is this, and then it'll just break. So if we go back and we run it, it'll give us a value. And that is all of our functions and our case. So thank you.